Hello viewers, welcome to Big By Physics. In today's video, we'll be discussing about the concept of Compton effect from the topic of modern physics. Well, this question I have taken is actually based on Compton effect, okay? And this is a probable JEE advanced question which can be asked in future JEE advanced, okay? So let's get started. The question says that a photon having wavelength lambda strikes an electron at rest. The photon gets scattered by an angle theta. Then you have to tell me the change in wavelength of the scattered photon with respect to the initial incident photon. Given that me, which is the mass of the electron, c that is speed of light, h that is Planck's constant, and theta. What is theta? Theta is the angle with respect to the initial direction at which the photon gets scattered. Basically, theta is the difference between the angles of the initial direction and final direction. Okay, so basically it implies the angle of deviation. Pause the video, try for a few minutes. Okay, let's get started. So before moving ahead to this question, I have discussed about a concept in one of my previous videos about energy. That energy of a particle moving in free space can be written as p into c whole square plus m naught c square whole square under root. And where p is the momentum of the particle, p is momentum, c is speed of light, m naught is rest mass. Okay, these few terminologies you must know before solving the question. And in the limit of non-relativistic speeds, then we can write it as nearly m naught c square plus half m v square, or you can write it p square by 2 m naught. Okay, and this comes out to be relation when v is much less than c, or you can write p is much less than mc, m not c. This is the limiting case. But while using this equation without considering limiting cases, we'll get an exact result. Okay, you may have tried this question probably using the concept of the approx values, and you'll get some approximate equation h by mec into 1 minus cos theta. Well, I have said the answer, but the thing is that it's the exact relation. Even if you get to approximation, you'll get the same, you may get the same value, but using the exact one, you'll get a more easier way to find the value. Using approximation, you may be handling with very difficult calculations, but I'll be strictly recommending you not to use such kind of things, because you need to deal more accurately. An accurate method actually yields a simpler answer here. You may be wondering you'll get a quadratic, but that's not the case. It's just a myth. So without further wasting time, let's get started. Then another thing is that momentum is conserved as well as energy. First, writing the momentum equation. What will be momentum equation? For considering px, you'll get h by lambda is equals to h by lambda dash cos theta plus p cos phi. From here you'll get p cos phi is equals to h by lambda minus h by lambda dash cos theta. P sin phi, just we are considering the momentum along y to be constant. P sin phi can be written as h by lambda dash sin theta. What is p square? P square, just square equation 1 and 2 and add. You will get h square into 1 by lambda square plus 1 by lambda dash square minus 2h square by lambda lambda dash cos theta. And p square c square, just multiply 1 c square, you'll get the required values. So this is one of the equation. In like, let's write it equation 3. So we have dealt with momentum. Now considering the energy factors, you'll get hc by lambda plus m naught c square. Second thing I'm writing is energy. This is the energy of the incident photon, and since the electron is a stationary, so p will be 0. This implies that rest mass energy will be there, so it will be m naught c square is equal to under root pc whole square plus m naught c square. Now this is the new energy of the electron plus hc by lambda dash, that is the energy of the scattered photon. Now transpose this hc by lambda dash left hand side and square the equation. You will get m naught c square whole square plus hc whole square 1 by lambda minus 1 by lambda dash whole square is equals to m naught c square whole square. Now expanding the pc whole square, you will get hc whole square 1 by lambda square plus 1 by lambda dash square minus 2 h square c square by lambda lambda dash cos theta. Now just doing some more evaluation, cancelling the m naught c square terms, you'll get something like, yeah, I have probably missed another term, that's plus 2 m naught c square hc into 1 by lambda minus 1 by lambda dash. Just doing some more evaluation, you'll get hc whole square into 2 by lambda lambda dash minus 2 hc whole square by lambda lambda dash cos theta is equals to hc into 2 m naught c square 1 by lambda minus 1 by lambda dash, cancelling 1 2. Well, I have cancelling the 2's, then another hc factor also. You will get 1 minus cos theta into hc by lambda lambda dash is equals to by m naught c square is equals to 1 by lambda minus 1 by lambda dash. Now cross multiplying lambda lambda dash both sides, you'll get lambda dash minus lambda is equals to hc by m naught c square or h by m naught c into 1 minus cos theta. So one thing to observe is that the wavelength of the scattered photon will increase basically. 1 minus cos theta is a positive term, right? So it's most probable that due to Compton effect, the scattered photon will have a wavelength larger than its initial value. Thus, the intensity or energy of the photon decreases. Well, that's common sense, because lambda will increase, then energy will decrease. Of course, the photon has struck an electron, so there will be some loss in energy because the energy is transferred to the electron. So, yeah, this is easy to say that it will decrease, but the amount by which it will decrease is h by m naught c into 1 minus cos theta. So this is a direct result which can be asked in JEE Advanced, and they may ask you to find the fractional change in lambda, that is the lambda dash minus lambda by lambda into 100. It will be the percent change. So hope you enjoyed this video and learned something new. And that's it for today. Thank you and have a nice day.